Hi students, welcome on the channel. So in today's lecture, we are going to talk about this question that why the focal length of a concave or convex mirror is r by 2. Like if we take the paraxial rays, right? And in that case, if we calculate, okay, yes. In that case, if we calculate for the paraxial rays, if we calculate the focal length, then it comes out to be equal to r by 2. Like you must have used this f equals to r by 2. Okay, it is going somewhere. Let me write down. So you must have used this f equals to r by 2. Like you studied this in the 10th classes, and now in your senior class as well you may get this, that focal length is r by 2 and we use in the ray optics and the geometrical optics. And as a 10th student also, if you are watching this lecture, so then it is also useful for you. So we are going to find out this relation, but if you remember, this relation is only valid in a certain condition. We say that the ray which are falling, they should be parallel to principal axis, and second, they should be paraxial rays. Okay, so we understand the first meaning, that it should be parallel, right? Like this, a parallel beam should be there, right? And then what is the meaning of this paraxial is that the rays, whatever that rays are there, they should be very near to the pole so that we can apply the approximations. If they are very near, so then of course, like this, if I take this ray very near to this principal axis like this, okay, try to visualize it. So then in that case, that angle of this normal, because normal will be the radial direction, so it will be a radial vector starting from the center of curvature to that point. So that angle will be very small. So that angle will be very small. So in that case, we get this f is equals to r by 2. We are going to derive that relation, okay, don't worry. But in that condition only we get that, right? So why the focal length of the concave or convex mirror is r by 2, we will discuss it. In that condition it will be r by 2. So here I'm taking that there is a ray which is falling at an angle theta like this, and now theta is not very small. Okay, I'm taking this, that it is not a small value. So then let us find out what will be the focal length, or we want to find out what is the pf value when the theta is not a small thing. Okay, so this is O point, and let's suppose this is some point N, and then we are taking this triangle OFN, and from the F point I am just dropping a perpendicular like this. Let's suppose that point is N dash. So see, if I take this is parallel to the principal axis and this angle is theta, then this angle should also be theta because Z angles, right? And this side is common. If this side is common, then I can say that this triangle O and dash F and triangle N dash F N, all these, both of the triangle, they are similar triangle. In fact, they are equal triangle because one side is common, one angle is common like this. So that's why it is going to be. So that's why I can say that if we drop a perpendicular like this, if this is the perpendicular, so basically this angle, so two angles are equal, one side is equal, so that's why these triangles are equal triangles. So I can say that the O and dash is equals to N and dash. Why I am able to say, because this triangle, these two triangle became equal triangle. Why they became equal triangle? Because two angles were equal. Basically all three angles are equal. If two angles are equal, then all three angles are equal, but two we are able to see geometrically, so two angles are equal and one side became equal, one side is common. So this, if one side is common, so of course if three angles are equal or two angles are equal, then they are similar triangle, and one side becomes equal, so then they become same triangle, okay, or equal triangle. So that's why equal triangle, and that's why I can say O n dash is equal to n n dash. Now we know that O n value is equal to R. Why I am able to say this is because O is the center of curvature and N is a point on the on a spherical mirror, and that's why if we connect a point from the center to the surface, it is going to be the radius of the sphere. So that's why ON is equals to R. And then of course we can say ON is equals to O n dash plus n n dash, and they are equal. So that's why you can say 2 times of O n dash is equals to R. So O n dash is equals to R by 2, right? Okay, we got this O n dash. Now let's again take this triangle. So we got this triangle like this, and we have a perpendicular like that. This is O, this is n dash, and this is F point, right? This we got is R by 2. Now let's find out OF value. So I can say that this angle is theta. Then I can say that cos theta is adjacent, which is O n dash divided by OF. So OF value is O n dash divided by cos theta. So O n dash is R by 2 by cos theta. So OF is equal to R by 2 cos theta, right? So this is OF value. Got it? Now OF value, if we can calculate, then we have calculated. So then of course we can find out what is the FP or PF. Okay, so yeah, PF, which is equal to the focal length, we are going to denote it with F. So that is the complete, if you look at this triangle, okay, just for your context, see, this is, we know how much is that, R, as I have mentioned here, and this we have calculated, okay, this is this value. So remaining one, of course you can say is that this remaining one is this complete minus this much, right? So PF is equal to F, which is equals to R minus R by 2 cos theta. So this is the PF value. Fine. Now this is the focal length, or this is the point of intersection if there is a ray which is falling at an angle theta and theta is not small. So then at this distance they are going to intersect with the x-axis. This is the distance. Okay. Now in this I have not taken the approximation. Theta is not very small. Now let us take, this is our last step of this part of question. So now let's take what, that theta is very small. Okay, I have written down with highlighted. Okay, yeah. So theta is small. If theta is small, so then cos theta, because theta is tending to 0, so cos theta will tend to 1, and that is why the focal length in that case, okay, focal length is equals to R minus R by 2 times of cos theta is 1, so focal length is R by 2. And this is how we can prove this mathematically, okay, although practically of course we can say, but okay, we can say that the focal length will be whatever that value is, R by 2. Okay, so there are the other lectures available as well on this ray optics topic. you can go through those lectures available on this channel, and there are the certainly very useful topic on the other chapters as well, which I have covered in my lectures on this channel. You go through them and try to learn them. Many JEE advanced, JEE mains questions are there, so PYQs, and I have solved them, so you can just go through them and understand the methods I have explained. If you have got any doubts, you can just comment that. I will try to resolve that doubt. And if you find it very useful, then you can of course share with your friends, and they will also get to learn all these concepts. And if you have any suggestion, you can comment below. Thank you very much.